Hey guys, welcome to part 3 of 3.3 day 2. In this video we're going to go ahead and finish up the last two problems, or I'll try. Example, given f prime to be negative on negative 3 to negative infinity to negative 3 and f prime to be positive on negative 2 to negative 3 to 2, and again f prime negative from 2 to infinity. So they're giving you the intervals, so if you want to, you could even just already try to graph this using the number line derivative test. It says here f prime is negative, which means it's decreasing from negative infinity to 3, negative 3, and then increasing from negative 2, and then decreasing from 2 to infinity. So already you know that this is a min, this is a max. I haven't even started the problem yet, but I already have a good picture of what's happening of the slopes. Letter A, if g of x is equal to 2f of x, what is the sign of g of negative 1? Okay, well, first of all, g prime. How do we get g prime if I'm given g? Take the derivative of g. The derivative of g is g prime. But what is the derivative of 2f of x? Well, 2 is just a constant. What's the derivative of f of x? The derivative of f of x is just f prime of x. There is calculus involved here, but there's no kind of algebraic method to find the derivative of a symbolic function. You just literally put the prime on there and you're done. For example, if I say h of x, what's the derivative of h of x? The derivative is h prime of x. But if I throw in something else, for example, if I say what's the derivative of g times h, that requires a product rule, which is g h prime plus g prime h. That's a different process. In this case, we have 2 times f of x, and the 2 is a constant. So all we got to do is plug in x is equal to negative 1, and we get 2 f of negative 1. Well, do I even know what f of negative 1 is? I don't know, and I don't care. All I want to know is the sign. Okay, which means I have to figure out what is the sign of f of negative 1. Well, f of negative 1 belongs in this interval here, and the sign of that derivative is positive. So I really have 2 times a positive number, which is positive, which is greater than 0. So g prime of negative 1 is positive. Letter B. Now we have g to be defined as something else. Okay, well, the same thing. Take the derivative of g. G prime is equal to, okay, now this is not as simple just put a prime on there. You do put a prime on there, but now that you have something in the inside, you got to multiply whatever this derivative is to the outside, so that my g prime of x is really 3 times f prime of 3x minus 5. Now in AP exams you may see something very, very similar to this. They may even put quadratic, they'll put in maybe ln x, they'll probably put in a trig function, but it's the same process. So I want to go ahead and find the sign of g of negative 1. So it's x is equal to negative 1, which means it's 3 f prime of 3 times negative 1 minus 5, which is 3 times f of negative 8. Well, where is negative 8? Negative 8 is here on this interval from negative 3 to infinity, which is a negative slope, and 3 times a negative slope, which means that this is a negative answer. So for B, g prime of negative 1 is negative for part B only. This is for part A. Last problem. The function s of t describes the motion of a particle along a line. So s of t is a position function. Find the velocity function at any time t is greater than 0. Well, how do you find the velocity? Well, first of all, let me go ahead and show this to you guys. Position, velocity, acceleration. The derivative goes in a down pattern. If I want to find the derivative of position, it's velocity. The derivative of velocity is acceleration. So s prime, which the derivative of s is velocity, and that is equal to 2t minus 7 for t greater than 0, because we know that time cannot be negative. Identify the time intervals in which the particle is moving in a positive direction. Well, positive direction means that the velocity must be positive. So first of all, I need to do my critical numbers. So this is my derivative, set it equal to 0. T is equal to 7 over 2. Draw my number line. In this case, I only have 7 over 2, which is 3.5. So I'm going to use a number before 3.5. I'm going to choose 1. And remember, I'm restricted because t cannot be anything less than 0. So my number line actually starts at 0 and it ends at infinity because I don't know when it'll stop. This is my critical number. What's the number after 3.5? And that is 4. So if I test these two numbers into my derivative, if I plug in 1 into my derivative, I get 2 times 1 minus 7, which is negative. So it's negative going down. So this represents s of prime, and this represents s, or v. You can say that's v is equal to s prime. If I plug in 4, 2 times 4 is 8, minus 7 is positive. So it's positive going up. So at what intervals is the graph in the positive direction? Well, it's positive from 7/2 to a positive infinity. And if you want to justify, you're going to say velocity is positive. Let me write that down. Velocity is positive on 7/2 to infinity because s prime of t is greater than 0. Now you can say s prime of t, or you could say v of t, but you have to make the statement that v of t is equal to s prime of t. If not, you're just throwing in things that you're making the reader a hard time to read this stuff. Okay. Letter C. At which time intervals is the particle moving in the negative direction? Which means, where is the velocity negative? And the velocity is negative from 0 to 7/2. So it's, you can say velocity. Velocity is negative on 0 to 7/2. Notice that I don't put brackets. 0 to 7/2 because s prime of t, which is equal to velocity, is less than 0. Identify the times at which the particle changes direction. Well, it changes direction at 7/2 from negative to positive. So at t equals 7 over 2, the particle's direction changes from negative to positive, and you're done.